So good morning, good afternoon, good evening to all. Welcome you to today's RWG meeting. One quick announcement. So I want to remind folks, anyone interested in presenting, we do monthly meetings with the requirements working group. If you have interest in presenting, if you'd let me know, kevin.orr@incosi.org. You can email me or Lou your interest in presenting. We have quite a few openings, so looking for some more volunteers to present. We're going to be listening on using AI for requirement development and validation of safety requirements. So our presenter today is Akshay Chalana, co-founder of Saphira AI.
Saphira.
So his team's built certified safety cases for robotic companies like Roco and 1X, including one of the very first humanoid robot in the home. Before starting this company, Ashke began his career automating reliability engineering and testing for the Model 3 of Tesla, then built a career in machine learning working on PyTorch and Meta at the Vision Pro at Apple, and led a compliance automation team in the financial service industry at Citadel Securities. He sees robotic safeties as the most important problem to solve in this generation to unblock adoption of millions of autonomous systems in every domain of life. So very interested in the topic. We will hand it over to you, Ashke.
Fantastic. Thank you so much, sir.
For folks also, feel free to ask questions in the chat. We have some pauses built in if you want to ask questions. It doesn't have to wait till the end.
A couple things from my side. I was going to quickly comment. You'll see my slides are very basic. I'm not a big design guy, so apologies for that. I know there's some fancy presentations that people give in this working group, but we unfortunately will not be one of them. And I also wanted to kick this off by actually expressing how grateful I am to Kevin for making this happen. I actually first started this company about a year and a half ago by joining INCOSE. I was completely new to systems engineering. I was completely new to requirements development. And Lou's material that he publishes online was incredibly valuable to me to learn about requirements management. And to give you a little bit of a story on that, the reason that we're presenting what we're presenting today is actually that when we started our company, we started by building a requirements integration platform. We were working on this interesting problem of translating interpretation of requirements into basically execution pathways from natural language. And because we weren't coming from the world of systems engineering, we needed exposure. We needed to learn what people were actually doing. And this whole community was super, super valuable for that. So before we dive into anything, just want to make sure that everyone understands I'm super grateful to have learned so much from all of you. And hopefully this is an opportunity for me to contribute some interesting learnings that can be valuable to all of you as well. All right. So yeah, that should be the beginning. I'm going to quickly walk through a couple things to contextualize this conversation. So title is up here. Kevin already ran through the basics of that. We're going to try to dive into specifics of how to build and use AI tools for requirements development and validation of safety requirements. So a little bit of this full life cycle here, and I've divided it up in some funky ways you'll see in a minute. So let's give a bit of context really quickly beyond what Kevin said about who we are at Saphira, why we're doing what we're doing, all of that. And then I'll go through the agenda for this presentation. So as context, at a high level, our company charters ourselves to build AI agents for product safety compliance. So we as a team come from backgrounds, as Kevin had mentioned, in hardware design, compliance software in a couple different industries, and functional safety. And in particular, you saw the basics of me coming from Tesla and Apple. Our head of product, who actually usually gives the first bit of this presentation, is Mahinder, who came from Intertech, which you guys may be familiar with as one of the main certification bodies for all kinds of different products here in the US. And my co-founder, Oscar, who will hopefully join and jump in for a couple things later in this presentation, comes from Amazon and Twitter. So has some really cool expertise and much closer to exactly the problem that we're working on. So the structure of this conversation is going to be, I'll provide a brief intro both to the topic, but first a little bit more to what we do as a company, just to contextualize how we've learned what we're going to share in this conversation. And then the 5 key points I'll want to go over that'll be most relevant to all of you will be first, how we construct multimodal context for requirement feedback and requirement validation, the key topics that we prompted at the beginning of the presentation. And then a big item that we'll talk about will be how you interface these artifacts with key analyses. So the biggest thing we learned, we'll talk about this later in the presentation, from trying to build a requirements integration system was that, in truth, management of requirements and utilization requirements is much less of a problem than how you write them. And I think that is exactly the charter of requirements working group, and exactly a lot of the discussion that happens here. And what we focus on particularly is where those emerge from, how you make sure that they're well informed, how you trace them to the analyses that drive your work. And throughout the first bit of this conversation, I'll contextualize why I think that's so important for the future of product development, the stuff that we're trying to enable by building what we're doing, and what you can already see in the kind of work that we're doing as a company in in humanoid robotics and in autonomous vehicles, spaces that are emerging at this point. Feedback and construction loop. So once you have some requirements, once you have some analyses, some trace between these and other related artifacts, how do you actually interpret changes to each of the artifacts in this loop? How do you build first your construction loop and then your feedback loop for what you're producing? And what we try to present is first a mapping of this to the activity that humans are performing and formalization of the review process that we all go through on our teams, and then interpretation of that in a programmatic way. I'll close out with some challenges and open questions, things that we're thinking about, and then pin things off with some closing thoughts. Okay, let me dive into the introduction to our product. Okay, so high level, what are we doing? Why are we doing all this? What is safety and compliance? Probably a question many of you guys have much better answers to than me. So this is typically a presentation. This was actually prepared for a robotic conference last week, ICRA, if any of you guys were there, and was meant for a broader audience. So just contextualize these things really well. So overall premise is that safety and compliance is a set of rules and regulations acceptable by industry, by regulators, similar to make a product safe to use. So that falls into three categories for a lot of the work that we do. We think a lot about functional safety. I'm sure that's what a lot of you guys focus on as well. So both, can a product harm the user, and how do you control that harmability through the actual design and operation of the system? So for example, in a lot of our work, we ask questions like, how do you prevent a humanoid from falling on a child? Or how do you understand if that's going to happen and action, for example, your control system appropriately? How do you build the requirements to understand how to implement that in your system and then validate it appropriately? We try to do something similar when we work on industrial systems like autonomous forklifts. How do you prevent them from crushing workers? The two other categories which are related to this, but won't be as much of a focus for what we walk through today, are of course electrical safety. So can a product cause a shock or electrocution for a user, or cause fires, et cetera, et cetera. And same goes for EMC, FCC certification, all of that. Can the product cause interference with other systems that we expect to work properly out in our worlds? Okay, so that's the basic context for the problem space that we exist in. So things that you guys are very, very familiar with. Let's talk really quickly, again, framing why we're approaching this problem in the way we are by talking about the role that AI is currently playing in other industries. This is, again, stuff that you guys are very familiar with because you're part of this world. You're I'm sure, using ChatGPT. Maybe if you're doing some software development, using products like Cursor. If you're like me here in San Francisco, you're using Waymos every day, all this stuff. And so, these 5 statements that we make are that we know that agents are super powerful. They can do really unique things that are much bigger than we thought they were. So they can actually start automating really complex procedures in our lives. AI can take actions within computers. Some of what we'll illustrate today is that some of this new tooling that's emerging allows us to overcome some of the bottlenecks of the previous generation of software, right? Where you had to rely on API integrations to be able to interface between different systems. And some of these basic things are starting to be overcome. AI is driving cars. That's, some of the products that we work on. There's so much complexity what's being enabled by some of these foundational models and hierarchical interactions between them. AI is diagnosing diseases, and it's doing research, writing code, and everything. Why isn't it contributing more to our engineering process? Well, the truth is it is, and we believe that what we're building and what we're going to teach you guys about today, that'll hopefully be useful to you, will be a really useful part of this. So narrowing that problem statement a little bit more, let's think a little bit about this problem of AI and compliance. A lot of the questions that I'm sure you guys are interested in that we'll talk about that's a prompt for this conversation is the risk that emerges. So, why is compliance a delayed gratification field per se? Why is it a space where there is not more of this tooling yet being adopted? And the truth is because there's high risk, and that's a lot of what motivates it. The work in these spaces to be done in very traditional ways, so that we don't end up with misses. We don't end up with structures of product development that are not well influenced by humans that take accountability for what's being produced. So, that's the starting place of why everything that's happening here is a problem, and why we believe there's a problem to solve. Okay. So what does Saphira actually do? And this will inform what we'll actually present throughout this conversation. Our vision as a company is to speed up compliance. So our goal is to look at products like robots, scientific equipment, automobiles, consumer products. Think about those four categories that we discussed: functional safety, electrical safety, MC, cybersecurity, so on, and short circuit someone's understanding to whether or not they're compliant yet, and then how they get compliant for their product. And so that's the context for what we'll present today. Let's start with a statement, which I think will frame the context retrieval problem that we'll discuss in most of this presentation really well, which is, why is this compliance task hard? Why is it slow? And there are three big pieces of this that we hone in on. The first is that standards are ambiguous, right? The source documents that influence how we actually do this work have a lot of interpretation left in them by design, because many of them are written for generalizable products that haven't yet been invented, that haven't yet been created. And they should still be able to provide guidance when engineers go and create those things. So that means that there's some ambiguity, complexity that we need to account for. That's exactly the kind of task that, when framed properly, LLMs are very, very useful for tackling. So that's how we'll contextualize the problem we discuss in this conversation. Identifying which standards apply is really challenging. Do you need to follow IC or UL standards? Do you need UKC and MARC? What's the difference between CE and CB? Totally different artifacts that mean totally different things, but something that maybe needs to be understood. I thought I met this requirement, but the NRTL says they won't accept it. Why? How? Why didn't I know this earlier? Is this ESOP good enough for my application? All questions that we need to be able to answer in a robust, structured, informative way. So again, framing what we're doing. Let's talk a little bit about some of the manual work that goes in. As you guys well know, this is a lot of what we're going to talk about in the analysis section of the presentation. There's a lot of analysis that needs to happen. There are artifacts like FMEAs, DFMEAs, FTAs that, when we learn about these as engineers, the thing we're shocked by is how qualitative a lot of these systems are. Right. So that's also the difficulty of requirements development with AI, right? This is a qualitative exercise. So how do you actually add in automation when there isn't already structure? And so that's a lot of what we try to do, and what we'll talk about in this conversation, which is framing and structuring the exercise really well. Okay. I'll skip over some of the other points here, but all in the same line of what we discuss. So our goal is streamline all of this, right? So take ambiguous, unstructured input. So general descriptions, product specs, market, end user environments, schematics, CAD drawings, data sheets, Excel sheets, BOM, all of that. And then try to derive these answers based on multimodal information. That's what we'll talk about particularly. So there are a couple of things that we usually mention here. I'll skip over this. We talk about the Saphira V model, how we apply this to agentic tasks at every stage in the systems engineering lifecycle. We'll come back to this. I think we're not going to look at most of this lifecycle in this conversation. So last couple of things I'll define about just the product, and that informs how we learn what we'll share, are that there are 6 pieces to what we capture and represent to our users. The first is applicable standards, clauses, and tests for specific products. So filtering down known information based on applicability. That's one big piece of what we'll look at in a minute. Then simplified risk assessment, FMEA, DFMEA, FTA, etc. Something that is well structured, again, something that both a human without domain knowledge can interface with, can be informed about, can learn about this procedure from, and something that can be used thus by an agent. Simplified calculations for intermediate components that need to be explicitly and in a standardized way calculated to derive your requirements, like MTFT, CCF, DC average for the kind of stuff that we typically look at. And then the ability to get all this information out via reports, via a chatbot that can actually interface with the project directly in many ways. And finally, a compliant BOM. So something that represents each of the individual artifacts that are being looked at, for example, each component within your system, and making comments on exactly whether each of those are compliant. So a couple of quick views of what this has looked like. And you'll see this in a couple demos that we share in order to demonstrate some of the implementation that'll be useful to you guys. So this is the entry point into our platform. You can see some of the different actions that we support. We use these kind of open-ended analyses methods to identify applicable standards, interpretation, etc. A lot of this presentation, I have these demos that I'm going to walk through at 4 times speed. So just to give you a sense of how some of this looks in such a way that we'll talk about the implementation of. You have these guided questionnaires that you can scroll through, answer questions about all kinds of different products. One of the things we'll talk about is the necessity of agents to generate questionnaires like this, to gather structured information back from humans for the purpose of providing effective requirement development feedback and then validation feedback. So you can see a little bit of what's going on here and a little bit of what comes out, which is really structured information at every granularity of relevance. So you can see, for example, that when we're doing the standards identification activity, we need to be able to provide, you can see, for example, when we recommend that for a given product, we need to consider ISO 13449, that has to come with a very clear explanation of, given that questionnaire, why this particular standard is going to apply. And in this particular case, it's because you've defined an industrial robot that interacts physically with humans, and it has safety-related control functions. Because it has SRPCSs, therefore, that fits the applicability criteria in the standard, and that's part of what we're going to apply. So you'll see in a minute why this becomes useful for requirements development. So hopefully it shows you one view into what we do. Let's scroll through, look at the last couple of things. You can do the same thing just by providing a description instead of a questionnaire. Oops, that's a little bit big. So I'll scroll through this. You can see we've just written autonomous mobile robot in a warehouse setting, and we're able to get the same thing out. Okay, let me scroll through a couple more things. Yeah, you can see this in raw standards view, so extracts of standards, in a Saphira standards view, which is an interpretation of all of this. So now we're into the actual meat of the conversation, which is probably what you guys signed up to hear about. So first off, why use agents for requirements? What does that even mean? And how are we going to discuss that and present that to you today? So let's stage the problem first off, and then we'll talk about the thesis that we're going to try to walk through in this conversation. So the problem, before we even define agents, is that requirements are vague, incomplete, fail to capture downstream impacts. That's the problem that you guys try to solve. That's everything that RWG publishes, really core problem. Second, manual creation and review of requirements, especially safety-related ones, are tedious. That's an okay problem. But error-prone is the big thing. So how do we build semantic representations of these systems that update with the right input? And okay, now we get to the actual statement of agents. So agents can augment engineers by surfacing context, suggesting revisions, and linking to relevant analyses. So let's define agent a little bit more closely here. So what we mean by an agent is not just an LLM as you typically interact with it, for example, a ChatGPT, but some LLM that has tools that can interact with the world around it. So in our world, that means that these agents need to have tools that can interact with your project directly, right? They need to have tools to get concrete, grounded information from reference documents like standards, like reference documents like your own data sheets and your own designs, and then also all the other artifacts in between that represent your product, your simulations, your CAD files, so on. So what we need to be able to do is break down the task of producing a recommendation, generating feedback, writing an initial requirement into active programmatic tasks that this agent can guide a computer program through. So that's how we'll think about what's being framed here. Now, one of the biggest benefits with using agentic systems is that you can surface and then iterate on that procedure back to the user, right? That's the most valuable thing to you guys. And the thing to think about when you build these systems and when you use these systems, which is that you as a requirements developer know better than anyone else every step that you're going to perform, right? you do the work of an agent in your own mind when you do this work, right? You have at least an ideal state of all the information you're going to use, all the analyses you're going to consider, and how you're going to aggregate that information. And the more you can represent that procedure in a repeatable or composable way to a computer, the easier time it'll have actually doing all that intermediate work. So that's what we'll talk about today. But the main thesis is that agents are only as good as the context you provide and the structures they can work within. So a lot of what we'll focus on is how you build context, how you build structure, the things that you are really going to care about. The first problem statement that we are laying out is how do you construct multimodal context? So what does this mean? So the idea is that when you're doing your work as a requirements developer, you have a bunch of input that you want to consider. And you want to make sure that this is received in the most semantic way possible, right? So you as a requirements developer are developing some SysML diagrams, some before you even get to the point of developing requirements, right? You're trying to model behaviors, use cases, etc. So you need to be able to make sure that those are properly ingested when you actually go about some requirements construction and validation process. That's one piece we'll talk about. You have a bunch of reference information that lives in spreadsheets. This, again, is structured information that can be structured in a kind of finicky way, right? So spreadsheets are great, but if they're not interpreted properly, then an LLM, for example, won't know what to do with that information. So how do we get that into the format that an LLM is actually going to use? Another topic is past requirements. That might be artifacts that are already stored within the system you're working in, like Saphira, or maybe within the memory of a product like ChatGPT, but very difficult to work with if you don't have a guided retrieval mechanism. And finally, standards. That's a lot of where our work is focused, as you saw from the beginning of the presentation. Those are all structured artifacts. But as you saw, structure is complex. Structure requires specifically defined and architected interactions. That's what we'll talk about in just a minute. There's also a bunch of unstructured information, which actually captures a lot of what's above too, right? These standards are PDFs, but you might have all kinds of PDFs that you want to reference when you're building and reviewing requirements. You'll have lab notes, you'll have design reviews. You want to make sure that all of this information is appropriately considered. This multimodal stuff becomes the most interesting, which is that you'll have images, you'll have block diagrams, wiring diagrams, tables, even natural language to describe your product. And you want to make sure that the right pieces of that get applied when you're actually running your operation. So let's talk a little bit about the origin of our mental model around this problem, and then the smallest version of this problem, which hopefully illustrates to you guys some of the stuff that you can start building and modeling your own workflows. Or if for whatever reason you decide to use Saphira, this is something you can totally do within the platform as well. Okay, so the origin of a lot of this work was risk assessment citation. So I'm going to scroll through this demo really quickly to walk through this. I'm going to mute so that doesn't come through. And the idea we're going to present is that we have a project that we're going to put together, which is going to be a safety case for a robotic system. We're going to answer some questions about that. So what kind of composition the system has. And what we're going to end up loading in is going to be all the applicable standards and an initial hazard analysis for this project. So let's see what actually came up here. So you can see what the agent put together was, to begin with, some initial suggestions of failures and then derived controls from that. So that's one level of structure we want to try to encourage. And then we try to come up with regulatory outputs. That becomes the piece that's most relevant. So the canonical example here is that we want to ground some work in particular documents, right? So you guys already think about this when you're doing particular work, when you're getting help from ChatGPT to do this work, that if, for example, you're trying to interpret a regulatory requirement, you want to provide the entire document or the relevant segment of a document to the agent that's performing that work. What if you can do that in the loop? So that's what we try to do here, right? It's this idea that what's happening in the background is as you're generating this component failure statement as part of your initial risk assessment of your robotic system, you're going and you're looking for just the relevant components from ISO 13849. So the way we set something like this up, which we'll talk about on one of the next slides, is a system like A system like Llama Index. So this is one thing that we can talk through at the right point in this conversation, where we present some of the code that actually goes into this. The reason tools like this are so important are that they let you break apart the documents that you're actually using. Some of the stuff that we'll present is, for example, that one of the biggest difficulties when you're building RAG systems is putting together the right chunking methodology, right? How do you break apart documents so you get sufficient granularity of those documents when you retrieve them back to be able to perform tasks like this? So one of the recommendations we typically make, and something that we have definitely espoused in our system, is there are amazing libraries like Unstructured, that's just the name of the library, that you can use to break apart your documents intelligently, right? So something that we try to do is when you're analyzing a standard, or even when you're analyzing a well-structured design document, that's an input maybe to a design document or a customer requirement spec for your internal requirements, really well-structured document that you can break apart by section instead of by page or by a bullet point or something, or paragraph, something like that. So if you define properly the way you're going to break apart a document, you make sure that you get enough information back in individual chunks that the answers you get back are actually actionable, right? And then you can apply the right structure, right? So in this case, when we're generating that first hazard analysis, because we go back and get just one entire section from 1349, we're able to make a statement regarding the relevant regulation. Then we're able to state the additional context for this task that that particular chunk is providing, which is that, okay, if you're going to assess component failure and suggest some actually mitigated measure, well, first you need to actually cast whether that measure is going to need to fall into a particular category. And there's information further down that it's linked from that chunk about what each of those categories are. So if any of you are familiar with machinery safety, you've likely come across these categories B1, 2, 3, 4, depending on the redundancy and diagnosability of some particular safety function, and the mean time to dangerous failure, all of that. And that's all information that we can integrate into the recommendations made here. So first point to take away is that if you chunk your documents properly, then you get back out information that in a single shot can guide the agent through tasks that it wouldn't otherwise know to do. So the counterfactual that we often present, which I don't think this document, this demo goes over well, is this idea that if you don't provide guidance like this, when you then ask the agent as a follow-up task to, for example, come up with a control as it has here, which is software validation verification, it actually will not know how to scope that, right? So all you're trying to do along the way in constructing this hierarchical context is define how you can influence the next action the agent is going to take. How do you get all the right guidance into the prompt in sufficiently consolidated representation, right? So how do you tell the system what to do, give it an example, but provide as little cruft as possible? And so let's talk about this in a little bit further detail in the rest of what's being provided here, which is that you can actually do the same once you already have some initial information defined. So we talked about that when defining the initial set of hazards. But for example, when you're building a risk assessment as one input to your requirements construction, what if you've already defined some of those hazards? So these are ones that we've already defined for a robotic system that we worked on. For example, these are hazards due to normal operation of the shuttle guide rollers, where there's inadequate shielding on guide rollers in the shuttle, and that creates a pinch point for the operators. So what do you do with that information? Well, the first thing you can do is when you load this in, you can actually retrieve the further relevant sections of the standard. So you can see, for example, for this first hazard, that specifically the section discussing category 3 safety functions is retrieved, because what was detected up above was that, hey, this was going to be a particularly high severity hazard. And that's the kind of thing that influences you having to build a particularly redundant and diagnosable function to manage that, to mitigate that hazard. So this is the particular section that you're actually going to need to consider. And that's the kind of thing that you can export and use in your final risk assessment. So the idea is that as you're developing your requirements further, now you have all of the right information at the time of development. So one of the key things that a copilot can do here that actually drives you forward as a requirements developer. So hopefully that gives a sense of the origin of this problem statement and how we're going to interpret this. Let's see if there's anything else useful here, which was, again, we added some more detail as to what this failure would be, this power supply failure that was present in the original hazard list. And we retrieve a section 1349 that discusses, what is this here? Category 2 control systems. So furthermore, something that might specifically be applied to power supply failures. Something that's explicitly discussed briefly in one of the notes in that section. Cool. So there is some more information that is present there. And you can now see how this all gets used in an open-ended chatbot as well right here, which is that you can retrieve any specific segment from the standards in a structured way. So what was the query that he ran here? Let me capture that really quickly. So what are the key safety requirements outlined in this whole standard? Well, now that all of this is grounded in some document, the information you get back can all be cited, and that is really critical. So that's what we see here. And you can see, for example, there's also reference up to what you've already been writing in your project regarding power source management. So all the kind of stuff that when you define your task to be done well and you ground the information well in some reference documents, you can get much more actionable insights that actually guide you through your development process. Okay, so I stated one problem and one way of thinking about constructing multimodal context. Talk about the origin of this problem. Let's talk briefly about how agents use this context. One of the key things that needs to be done along the way is that you need to extract key entities, right? So there will be definitions of functions, definitions of hazards, definitions of architecture components. And as we perform recommendations from an agent like this, the agent needs to know when it's trying to reference particular types of entities. So that's one thing that we'll talk about in a minute, which is that again, what you try to do with these agents is you try to sequence the activities that they're going to perform. So we typically call this chain of thought prompting. You can do this both at the prompt level and also in terms of the structure that the first LLM calls in your sequence are going to output. So for example, when deriving one of those recommendations that you saw up above for a new control, you can guide the system through first an entity extraction process where you say, hey, to be able to make a decision on this, I'm going to need to understand all the applicable functions. So you provide it all the relevant details, and then you ask it to actually provide a function definition as one of the first things. And now, instead of having everything in your context as when you're answering the question of how to develop a control measure, you specifically have a definition of a function, and maybe a definition of a hazard, and a definition of those architecture components. And maybe you've also produced an actual block diagram in between. There's some function that might produce that, and then attach that into that multimodal context that you're sending out to the LM for the final task. So the idea there is you want to break down your task as much as possible. Again, one of the things that I really want to hammer home in this presentation. The other piece is, what if you actually want to interpret some of those multimodal inputs, such as diagrams, to begin with? So I think we have an example of that somewhere in this conversation. Trying to remember exactly where. No, I think that might have come towards the end. We included an example of diagram parsing. But again, one of the key ideas is that if you want to interpret structured information, one of the best things you can do is represent it in easily interpretable formats for the LM. So one of the biggest things that we've learned, which you'll find if you spend time researching how most of the agents are constructed, is that LLMs are heavily optimized to handle JSON data today. So representing everything as JSON becomes particularly easy for these LLMs to interpret. But that's not the end of the story. So you have some benefits. So we think about, we're systems engineers. Many of us work with SysML. SysML v2 is this great YAML-based format that is easily interpretable to a text-based interaction system. But what this actually teaches us is that YAML itself is not descriptive of enough of a format for these LLMs to interact with on a really detailed level. But in fact, SysML itself at a high level may not be either. Instead, what you want to do is you want to extract all the right information for your task. So, for example, one of the biggest things that you might find, and this is something that we've really invested in, is how you represent a graph becomes really important. So, not just having like the JSON interpretation of your systeml v2 YAML as input to one of these prompts, but for example, going a step beyond that and representing that graph, if you guys are familiar with traditional data structures, as an adjacency matrix is something that some of these LLMs can handle particularly well. Actually, we've discovered that more than adjacency matrix, a proper adjacency list is something that's particularly interpretable because it builds this continuous context about relationships as it reads through your JSON adjacency list. So when you think about providing the right context to your LLM to perform some task, sometimes you need to optimize for the actual data format. And that's where tools like ours can be particularly useful, but it's also where you can already adopt some of the best practices that we've pursued by using some intermediate tools as you even use tools like ChatGPT. All right, so that's one point we wanted to make. We had an example of how you could combine input from a block diagram and a hazard table to generate a combined update to a requirement, such as for an autonomous vehicle, perception systems, behavior in terms of detection length in different lighting conditions. So the way we laid this out, for example, is this example we'll produce is we have this autonomous vehicle project that we were just working with yesterday, where you have a requirement like a safe stopping distance for the truck. This is an autonomous truck. And one of the first things we do in this sequence of activities is we suggest a task that the truck is performing. So this is kind of going backwards. It's trying to extract like parent details once you've already written some requirements, just for the sake of this demo. You can see some requirements that we generated, such as your requirement for universal applicability of the collision detection system to ensure collision prevention. So something that might be like a safety goal that influenced some initial requirements that you presented here. And what we do in this example is now we take one of those particular tasks, so auto brake activation, that may have been a trigger for the underlying requirement that we saw a minute ago. So this is a child of that requirement per se. And we go and we say, identify hazards off this to build a hazard table, the example we just put up. And given some input from appropriate standards, what we come up with is these three hazards that are particularly going to be problematic with this system. So false positive braking, false negative, no braking when obstacle is present, environmental factor interference. And now you can build linkage between all of these artifacts. So you have all of these hazards down here, these default components right up here. And now we can go up to requirement 1 that we'd already had, which was some vehicle obstacle detection minimum range related to the sensing range on the previous slide. And you can assign as parents all of these hazards that are, for example, inputs to this requirement. And as we go through and assign those, we'll go through and we'll trigger that. Once we trigger that, we'll go to our Copilot. Oops, sorry, I scrolled through that really quickly. We'll first upload a block diagram of the autonomous vehicle to that particular requirement. So that, shows up right here. So this is like an overarching block diagram, one architecture component you want to associate it with this requirement. And then you ingest all of that information when you go to use the Copilot to update the value of this requirement based on the associated hazards and the linked block diagram. So you can tell it, propagate this change to other fields. And as soon as this returns, you'll see that the input of those hazards, all the appropriate context, is used to extend the obstacle detection range with this reasoning. And you can see, for example, the further reason and user that are also iterated in this particular iteration lifecycle. So you can see, for example, that, hey, we both changed the actual value of this requirement, and we changed the motivation for the requirement. And that comes because you have a change in the thread of how you got here. So again, what we've crafted is a really specific hierarchy for how you're making changes in your requirement development process based on all of these associated artifacts, some of which you would typically represent in your systems engineering lifecycle, some of which you wouldn't. And that's how we put together an actionable update your actual requirements. Cool. So that was the example I wanted to share here. Instead of walking through more of these demos, I can quickly scroll through and show you guys a little bit more of what we would have presented.
Question in
Awesome.
the chat.
So we talked about using an LLM to parse out information from standards. Are we working with the standards development organizations to get their permissions to do this? I know SAE does not allow this, and I think most others do not. You're totally correct that we are actively working with ISO and ANSI on exactly these. One interesting thing we found is that there are a number of standards publishers that, due to the utilization of those standards, are actually fine with you using the standards in this way. So some of the things that we found, for example, are we do a bunch of work with particular sections of the EU Machinery Directive, and because most of those are published publicly, the licenses actually say that you can do this kind of work. But what we do for most of our actual commercial engagements, otherwise, is that we have specific licenses that we put in place with ANSI, ISO, and so on, where we license these standards for our own use for R&D. But then by the time we go to a customer, we do one of two things. Either we validate that they've licensed it directly, so that way there's no unlicensed use of the standards, or we do something else kind of funny, which is that we actually relicense the standards. So you'll see these online. There are a bunch of other resellers of the standards, and we have one of those reselling agreements that we're putting in place. That piece is a little bit less defined right now, but hopefully that answers your question a little bit. How we interface with copyright challenges for this particular problem. I figured this is probably a good break point for some of the questions. So I'll run through the rest of those, and then we can definitely tackle more of the content this year. So Lucas asked a fantastic question about how we deal with non-deterministic behavior of AI tools and how it manages to ensure traceability between each generated artifact. When handling different regulations and requirements, we could quickly lose information traceability every time we play an AI-based tool. That is a fantastic, fantastic question. I think the best way to do this would actually be, I can quickly shift over for a second to our tool and show you a little bit about how this actually comes to play in reality. So one of the things that you'll see is that for every item that gets generated, so what was the example I was using earlier? It was the autonomous truck project, I believe. There are two things that get stored. So the first is that for every requirement, we store some set of parents or some set of origins of this particular requirement. And so why is this important? This is particularly important because that lets us maintain that traceability every time we perform a new action. So the biggest way that we try to solve for this problem of maintaining traceability is by making it really explicit in the underlying programmatic system. So if you capture that origin every time you do a derivation, and you capture it in a versioned way, you can make sure that you don't lose any of those origins. You can see one thing we do, which is that we store a bunch of external links that are derived and used when you are putting together this case. You can see that every time context is retrieved for a particular action, all the sources are explicitly saved. And we save not just the origin of the source, but also the original chunk that was used and the interpretation of the chunk. And so that lets you do is it lets you make sure that once you build some traceability, you can always go back and reference that, and the agent always goes back and references that when it continues performing more actions. So this is one of the whole ideas of persisting the context that you are using. When you use a tool like this that's structuring your interface with the LLM, what you guarantee is that you always store that information. You can't make that guarantee when you're using just the memory that's baked into a system like ChatGPT. So that's kind of the unique value proposition that we provide. The last thing I'll pull up as example is we use this one as a demo for a lot of things, is palletizing robot. I think for hazards. All right, the way I can tell this is if a norm is populated right here. So here's the energy isolation protocol. It's one particular control, and you can see that the exact section from which this reference was extracted is persisted. And then down below at the bottom of this, the actual content of that section is also persisted. And therefore, you're able to use that information again. That answered only the second half of the question. The first half of the question was, how do you deal with non-deterministic behavior? And The biggest way that we try to tackle this is kind of this motivation that we're driving throughout the conversation, which is that you try to make the action of the LLM as deterministic as possible. Not deterministic in the sense of you know exactly the computation that went into it, but at least that you know the traversal through a tree of actions, right? And you define as little variation in that as possible. So that's what we try to do to limit the negative impacts of the AI tool. And hopefully that's what we can help many of you understand how you theoretically could do if you were to implement a system like this or adopt a system like this. Okay. I don't know if I answered your question properly, but one of the things you'll see at the end of the presentation is I have my email and my phone number and all that. So please do shoot me a message and all that if you're interested in talking about this. Okay. And make said, okay, the usefulness of the agent is predicated on the context presented. And realize the total context may not be totally understood. So how does the agent compensate when this is the case? That is an amazing question and something that we spend a lot of time thinking about. So the way that I had started illustrating this in the rest of my deck was this idea that what we try to do is ground as much of the recommendations that the agent makes in analyses, right? So the idea here is that there are two things you can do when you have a function trace from a given activity of what context an agent needs to fetch. So the first is that you can actually define gaps in information. So this one I did not include a good demo of, but something that we typically present is that if we go back to that example we shared a minute ago, you're iterating on the requirement for the detection distance for obstacles by this vehicle. For example, one of the biggest things that may not be well defined is other criteria regarding the stopping distance that may influence this, right? So we said that we started everything by saying that the truck must maintain a safe stopping distance of 50 meters, at least 50 meters from obstacles. So, okay, we know the stopping distance, but how do you interpret that, right? So to be able to make a proper recommendation here, the LM also likely needs to understand, for example, the placement of the sensor or sensors that are composed for some fusion on the vehicle. So, for example, this distance may be different if this is a LiDAR that is roof mounted or a LiDAR that is ground mounted for a truck. And as a result, that information may not be contained within the project. So we have an interface that's not well presented in this demo, but whenever we try to identify examples like that, we prompt users back for that information, and then we store that as implicit requirements in the project. So you have some explicit requirements that are written here, some that are starting places, some that come from customers, some that come from outside, some that come from other tools, some that are derived from analyses. That was the second half of what I was going to say here. And then some which require more input. And those more input ones end up being kind of the implicit mapping of your product. So in fact, that was actually one of the very first things we tried to solve as a company that we first learned from RWG, which is this idea that there are always so many unknowns about products. How do we uncover those unknowns? How can an LM be guided to get that information out of a user? So you saw that questionnaire we did earlier. That's like one way to represent this. And we try to model that in as many points in the system as possible. So if you're interested in this, I'd love to talk about this afterwards because part of the vision for our company is that this task is a really well-defined task to build this new type of agent, which is what we call a continuously human-in-the-loop agent. That is something that always relies on ambiguities that it does not have the right information to. All it knows is that there's missing information, not exactly the form that information takes. And so a lot of what we're trying to do to solve that problem as a research problem is build examples for this and then guide the system to use examples every time it has to gather more information from a user. But that's where analyses come in. So I think this is probably a good prompt. I know there are a bunch of other questions I'll come to in a minute, but to talk about a little bit of this interface with key analyses that was part of the rest of the content here. So one idea was that there are three particular analyses that I think we've made reference to a little bit in the product so far. We have HARAs, we have FMEAs, and we have FTAs. So analyses that all of you guys are likely familiar with. Um, each of these is something that uncovers knowledge about a product as well. So the idea is not only that the system can prompt users back for information, but sometimes it can try to derive that information itself. And so this was one example. Another example that we really like to share on this is, let me find where exactly this is in my deck. But we do some really cool stuff with hazard identification. Yeah. So, for example, this again goes to multimodal context. One of the things, I'm going to mute this again as I play it and scroll through. One of the really cool things we can do is you can start a HARA based on public information of a product. So, say at the beginning of a project within Saphira, you can just provide an image of the robot you're working on. This is an old Amazon robot. And or beyond an image, you can actually provide a CAD model. And the cool thing about a CAD model is that it can tell quite a lot about a product. So I do that right here where I upload, you'll see in a minute, a step file. And what we do with this step file is to begin with, we come up with a template view of that step file. So that is, each of these different viewpoints on this other related robot. This was a predecessor to Astro called Vector. Um, the uh, the really cool thing you can do now is, as one of those tools, when in the hazard identification agent, you can add a callback that says, I'm missing a piece of the view of this product. Can you please go and zoom in on a different angle of this product? And then you can iteratively guide the CAD viewer to take a specific shot of the product, or do something like derive particular dimensions of the product. And that's another one of these ideas where there's actually a lot of implicit information with the right unstructured documentation that someone provides, whether it be a CAD model, a video of a product, a prototype, something like that, that can be derived if the agent knows to go and derive that information. So that is kind of the second half of this problem. The first is prompt the user back for as much information as possible. The second is there are ways to go and derive this, go and try to derive it. And to derive it, you can build interfaces to all these other modalities of data. Cool. Amir, you asked about IL5, IL6, Azure Government, local LLMs. Really, really good question. So this is a funky thing about the fact that we learned a lot about this from the INCOSE community, but traction we found as a company has been in completely different industries. So biggest thing we learned, we're a venture backed startup. We have to build and find customers really quickly. And as a result, most of our work is in the commercial sector. In fact, all our work right now is in the commercial sector. So while we've invested in IL5 compliance, the default version of our tool that you guys can log in and try out for free at the end of this presentation is not IL5 compliant because we don't have any customers that are demanding it, and it's a very expensive procedure for our team to go and do that if we don't already have someone on the line. So the cool thing is we support all of it. We've done most of the preliminary engineering work, but right now no one's asking for it because we're able to move much quicker with our commercial customers, and that's where we focus our work. But what I will say is that we actually do quite a lot of work with commercial aerospace and with extremely IP sensitive organizations such as chip makers. And for them, we definitely do invest in local LLMs, but not for the sake of setting up a cloud IL5 plus environment or something like Azure Government or what's it called GovCloud in AWS, but rather for hosting in their own data centers or even on desktop machines in their facility. And so what we've proven is everything in the demos, we use OpenAI GPT-4, 4.0 for most of this. We use Gemini for a bunch of the larger context document-driven workflows. But as we talked about, you kind of need to break most tasks down to have much less context, just the right context. But we've been able to do the same with the Gemma small language model series. So the Gemma 8B model that's open sourced by Google offers multimodal capabilities, and we've been able to demonstrate that because of this context restriction workflow that we've illustrated in this presentation, we've actually been able to get really good performance out of that as well. And you can run it on a single GPU machine. I have an M1, this is like an M3 MacBook Air. It even runs on this machine with 16 gigs RAM. So it's something you can do pretty easily locally. So that's one thing I want to offer to you guys too. Like outside of all of the fun requirements discussion stuff, if any of you want help or guidance on local LLM stuff, that's definitely something we can help with. That's stuff we understand pretty well and can send you the right tools on help you get set up. It's a lot of fun. Cool. Okay. Amir responded to Travis regarding security is a big priority. Their luckily model is getting improved for it every day. One thing I was actually going to note, I have no idea what the geographic composition of attendees in this meeting is, but we do a lot of work in Europe. And so something we've invested in really heavily is GDPR compliance. And so one of the biggest utilities of local LLMs is even for cloud deployments, that ends up being really useful to fully localize data within European data centers. And so something we've invested in really heavily there. Really good questions about just the structure of the application.
The morning session hits European areas and afternoons more US
Perfect. So hey, I mean, hopefully, if there's anyone doing LLM development on the European side, if there's something we can help with, let us know. Always here as a resource. Cool. Leslie responded that SE has had in-house projects to parse standards of LLMs. We have found that this can be challenging based on how standards are written. They're written to be read by humans, not machines. There's often ambiguity or different potential interpretations. How do you work to overcome it? It's basically the software rule: garbage in, garbage out. I'm not saying the standards are garbage, but many standards are very challenging for LLMs and other AI engines to accurately interpret. Material standards are often written in outline form. Part standards have lots of data embedded into the images. Other standards have nested tables that can be challenging to follow. This is an amazing question and something that we invest a ton of time into. So let me show you guys something really quickly outside of the deck that I think will be a good illustration of this. So this Palletizing Robot 2 project, we were trying to certify according to, let's see, I think the best example for me to show is actually going to be one that we've been working on recently. So let me add a framework. I'm going to add ISO 10218-2 to this project, which is the most relevant. This is actually what we'd use for a palletizing system. Actually, going to remove 13482 because that's not relevant here. And what you'll see once we have this up and running is that we've done a bunch of work to structure the standard, restructure it in first a navigable way for an inexperienced human, and then deriving that into a navigable format for the agent. So I'll show you what that actually looks like. So when we dive into, for example, some particular requirement within section 5 of 10218-2, one of the things you'll find is that there are a ton of references within every one of these standards. So this is actually a little bit adjacent point to the two key points you made, which are about nested tables and 2D images. Even 3D images per se, and that's a big problem in a lot of the robotic standards we work with. 3D images, not in terms of representation, but like casting on the paper. So a couple of things that you find are that one thing we try to do is we try to explicitly interpret every reference as available. So you can see here that, for example, every reference to 12100 lets us click in and understand exactly what piece of 12100 would actually apply to this palletizing robot. So a work cell is going to require some sort of hazard identification. So that's what it's going to pop up in a minute, which is it's going in, reading 1200, it's extracting just the relevant sections, and it's coming back and it's telling me how I would actually apply that to a robot picking boxes off a conveyor palletizing solution. So what this starts to model is that the first thing we can do is take existing semantic information from these documents and then map them into function calls that an agent can make to retrieve more information. So that's the first thing. Now, what we're trying to do is kind of a research project is see how we can do that with images and with tables. So when it comes to images, the first thing that we do is that instead of feeding documents raw to LLMs, you can see that first we try to break it out into this textual organization. One of the things we get out of the same thing is the JSON parsers we use to construct this also split out all your images And so those images can be stored as separate artifacts and then additionally added into the context of any one of these calls. So, for example, when we assess compliance of an entire project to one of these particular sections, where there are drawings that are present, we include that in the prompt that is provided. There are a bunch of other tools that we hope we can develop that a lot of our friends are working on building here that I'm really excited about. So one is that there again, so we talked a little bit about how we built this CAD agent that can navigate around an existing 3D model to retrieve the right views on a product. But you can also go a step further and you can actually try to derive a 3D model off of 2D information that you're provided, or introspect a 2D drawing that is presented, and first retrieve all the relevant interpretations of that drawing, and then feed that interpretation to the final agent. So that again becomes one of these function calls that we add into this increasingly complex system that says, hey, when you have a drawing, the first thing you should do is not just include this in the context, but also go and annotate, highlight pieces that seem particularly relevant to the question being asked, or reinterpret this in the setting of this particular product. So I don't have a great example of that because this is a research project we're currently undertaking. But for example, something that I'm really excited about there is, when 10218-2 and it's ISO TR 20218 that we're currently working on, when they discuss how to interpret safety zoning for a robotic work cell, one of the big things that they do is they lay out examples of given a particular type of robot, what the conical zones or other segmented zones could look like around an area of operation, how that could be made dynamic. That's one of the biggest things that you want to reinterpret and that you would implicitly reinterpret as a human reading that standard. So one of the things we're trying to do is we're trying to add as an intermediate function call for that particular assessment, hey, reinterpret this image in the context of this differently sized robot. So something that has slightly different dimensions, that takes up different space, and has a different shape. That's the kind of thing that gives you the right information up front. So principle, again, aligning with the general theme of this presentation, is that the way you get around some of the interpretation problem is you break it down into smaller and smaller tasks. To get back to the last piece that Leslie mentioned, one of the ways that we've tried to tackle nested tables is we'll extract tables as external graphics to begin with. Then we'll actually have a first pass by the LLM that tries to look for nested tables. And we do this in a couple different ways. So one, there are document understanding models that are really good at spitting back out, hey, this is where I see a nested table. I'm going to extract that, ignore in the original one, store where it belonged, and then get the flattened version of that in a secondary or a tertiary function call. But the other thing you can do too that we've kind of bootstrapped for example, a hazard identification workflow I showed earlier is VLMs are actually pretty good at getting you bounding boxes around arbitrary items. And so we're able to use that to then do in-the-loop image editing. And ultimately, this is the kind of thing that the GPT-4V vision editing APIs will allow. But in the meantime, we can kind of bootstrap that by saying, let's extract that. Let's explicitly remove it from the interpreted one. Then let's take that clipping and do that work manually. So we try to come up with as many function calls as possible to interpret the ambiguous information in more structured ways. One last thing I'll say, Leslie, we had a chance to meet a bunch of the SA team working on this project at WCX last year. We didn't get a chance to go back because you're not doing a whole lot of automotive work this year. But if you're still in touch with them, would really love to continue that conversation offline. Because we know one of the other partners that SAE is working with on this, and we think there's some great learnings that we can contribute to that effort. So definitely want to make sure our studies can contribute. Next question by Oliver, which hopefully relates to the rest of the items here. It appears from the evidence table that Saphira is able to manage requirements similar to Doors NG. Is it able to export documents that can be placed under configuration control? Very good question. We try to do this from a bunch of different places. So for example, you can take a particular view in your compliance evidence, for example, your risk assessment, and you can export the whole thing as an Excel file that you can place under configuration control. So this is one possibility of what you could do. So that's an example of this. You can also reformat the structure of this in whatever way you like. So for example, we mentioned earlier in the conversation, there's a bunch of implicit stuff that we capture. For example, the justifications for every hypothesis that the AI presents, such as the justification for the severity that is suggested, like, hey, the system is just 1 foot tall and is soft, so it cannot cause severe injury. I think that's actually something I typed in to justify lowering the severity, but you get the sense of what I'm going for. So you can include as much information as possible, or as you'd like in that controlled version. We also have mechanisms if you want to do configuration control within the system to release block certain artifacts, including external artifacts. So if you've linked, for example, with this hazard, some Jira task that is discussing execution of interpretation of that of that hazard into your actual design, or maybe a document in Google Docs or OneDrive where you've done some of that design, then we'll lock a version of that, we'll capture it, and we'll include that in the version control. And we store and surface a lot of that in our reports view. There's nothing that shows up for this project, but I think I can go back to autonomous truck view, where you can see exactly how this is composed. I think in a minute, there may be some release reports that pop up, or I may have broken this because this is not in really active use, but definitely something we thought a lot about. The configuration control thing in like our main work as a company comes up post initial certification usually, or like when you do a release cut. Post certification, because with most of our customers, you don't start really the next design cycle until after one of these. And so that's stuff that's like coming up now. We like design early for different customers. Fun things. Cool. Okay, second point by Oliver. I've used AI to generate requirements and analysis on topics where I lack expertise, but I found that mistakes are often made by the AI tool, but I've been able to reach a satisfactory point by carefully reviewing and challenging each of the steps that the agent took. Has this presented itself as a problem, and how does Saphira deal with them? Again, a fantastic question. So there are a couple things that we try to do here. And I'll try to, instead of repeating myself, try to speak about pieces of what we try to do that I haven't yet touched on. So this one of the big ideas that I'm excited about in agents is the idea of structured memory. So those of you who use ChatGPT heavily have probably seen the add it to memory pop-up that sometimes show up. And you can go and view all the memories that the system is storing about you and your product and so on. So we've been trying to develop really explicit versions of that for specific tasks. So the way we store a lot of this is we store these different settings for given projects. We store, for example, continuously evolving project description. We follow test generation prompts. One of the things I illustrate later in the deck is this idea that for many folks, we end up devising these intermediate checklists. So for example, that'll be like a classical AS9100 100, quality manual checklist or something like that. And every step in that checklist is going to have specific insight from your application. And so what we try to do is every time this feedback is captured or provided by a user, we try to summarize it in a way that can be prompt injected into the next time this agent performs a similar task. So for example, if you correct the agent and you say, hey, when you wrote this particular requirement as part of the checklist, then you did not consider this context of this product. So for example, the last time this really came up was with a medical device project we were working on. And the agent kept on missing some particular references to like the typical FDA approval process. And it kept on like skipping procedures in what I was mentioning. So we went back and like we wrote just like a small guide that said, hey, this is what always needs to be done. And then that was included in every prompt as one of the example contexts, and then it stopped making that mistake. So the idea is, again, is exactly what you guys have been doing in your own utilization of ChatGPT, just trying to systematize this, which is that you have a whole lot of context that every one of these agents is utilizing, and you want to make sure that that is ingesting personalized context as well. And it should be doing so in as explicit a form as possible. So you should be able to control that. So again, I it's a little bit hard to get to that point of displaying that exactly. I'll see if it comes up later in the deck. But if you're interested in talking about that more after the fact, would definitely love to and share best practices that we have for using ChatGPT and then also for using and building tools like ours. And then, yeah, the second part of that question was, for example, requirements that haven't been iterated to an approved state clearly flagged. That's an even separate question that's also fantastic, which is that everything that is suggested is highlighted. So we saw that back here. I think palletizing project was a good one. Demonstrate this. Let's go back here. Okay. Thank you guys for so many great questions. This makes my life way easier because I have no idea if I was just rambling into thin air with the actual presentation. Um, let's go over to the risk assessment and view exactly this. So you can see that every unreviewed statement by the agent is highlighted in yellow. So the typical interface here is that when a user sees something that is unaccepted, this blocks export or release of a given state of a requirement or hazard statement or compliance statement, whatever it might be that's stored in this evidence table. And you can change that. So I think the best way to do this is typically back in the requirements view. You can come back in here and you can add, for example, that severity, and you can see that it was highlighted here, and you can add a label and you can say this one is good to go. And we require a workflow like that to actually approve any change that the agent is making. Okay. Yeah, Leslie, would love to talk after the call. Okay. Lou, there are lots of considerations when addressing compliance with standards and requirements. The RWG video on standards and regulations compliance can be used. Amazing. One of the biggest things that I'm really excited about is that a lot of these materials are things that we should be using, especially in projects that all of us work on together, as explicit context for those projects. So we can explicitly make sure that, for example, key slides or key statements from this presentation are actually loaded into any projects that our LG members perform on a platform like Saphira. And we can walk through exactly how we do something like that after the fact. Okay. Nicole asked a fantastic question on how AI can find the unknowns that need analysis. That is a very, very good question. And something that I don't actually have a really good answer to. So the way that we try to do this right now is the thing that for all the AI agent purists in the room separates us from being just an LLM workflow automation to actually being an agent, which is that you create a while true loop, an infinite loop within the system. So the idea is that what the agent is prompted to do in most of these activities is keep on going with the backlog of what it's produced until it no longer thinks that there is uncovered information. So that's not comprehensive and it's not deterministic yet. And we're actively trying to figure out how to make this deterministic. So if you have ideas on that, I'd be really excited to talk about this. We had some meetings about this yesterday with some of our prospective customers where we were talking about, okay, can you build a syntactic model of some of the coverage items that you want to analyze? So for example, when you're building an FMEA for, it's actually really easy to imagine building an FMEA for, a PCB, right? Like that's a really well-defined analysis, coverage, state, validation workflow, right? So you can say, hey, well, I need to make sure I have every one of the key failure states captured for every component, and then for every like subgraph of components, and every subsystem. And you can build up like an expected map of this. But you can also maybe start to do this with some additional understanding of different types of products. So we don't know exactly how to do this, but what we're trying to do is like, this is something that kind of relates to, I think, what a lot of systems engineers do implicitly with their system modeling, where in your architecture, you explicitly lay out every layer of impact for each analysis that's being performed. And then you restrict the boundaries of analysis and you say, keep on going until you've covered every item that should be covered here. That's the closest we get to this right now, but there's a lot more work that needs to go in there. So you asked me the hardest question because that's like something that we're really actively focused on. Sarah asked about demo videos, information on integration with MBSE tools like Java. Cool. I also don't typically consider Java an MBSE tool, but definitely happy to answer that. Minimum, one of the things I'll do afterwards is I'll share our YouTube channel where we have a bunch of examples of our interaction with Java. And one of the really fun things we do, so as you can see, as we've built up all of these tools, there are some really funky intermediate tools that are really useful for like human workflows with MBSE tools and requirements tools. For example, one of the main things we do that we shipped for a customer a little while ago is you can import non-MBSE, quote unquote, MBSE diagrams and then bring them into MBSE tools. And that actually was an example that I had in the deck somewhere. So in this case, we were interfacing with a classic automotive analysis tool called V-Way Visual Pro, if any of you guys have used this. And we wanted to get information out of that into enterprise architects. And so we were able to really quickly look at a screenshot of the graphic, the loss function flow down that was modeled in V-Way, and then interpret this into which you'll see here is first into the Saphira intermediate representation, our IR, if any of you guys are familiar with compilers, where we extract all of the hierarchy and all of the items that were there using a VLM. And then we export this as an XMI that is interpretable by Enterprise Architect. Also, you can see one of the funniest things I had to do for this was figure out how to get Enterprise Architect running on Mac, which was definitely a journey. And you can see what we're able to do. So you can see that there's some information that gets missed, but there's a bunch of cool stuff you can do. So the latest on that road was we integrated with Lucidchart to capture behavior diagrams that we wanted to add MBSE-like logic on top of. And then we added some of that logic within our systems, such as simulatability and whatnot. And then we exported it into Java. So we set up a sync mechanism where, oops, sorry, I realized that link no longer takes me to enter the information. It just like starts the export. But it like creates a sync mechanism where as soon as you make an update to a particular behavior in your Lucidchart, it syncs to the Saphira IR. The Saphira IR will do any grouping or enrichment that it was trying to do before, and then it'll write it back out to Java. And we can do the same with doors, with Polarian, whatever you need. If any of you guys use Flow, I'll share some videos. Sweet, complying with safety and security standards will not result in a system that is safe or secure. This is an amazing, amazing point, Lou, and is the really fun thing about our vision as a company. It's comparatively easy to build a compliance company because you have a business outcome that is guaranteed and required. It is much more exciting to build a safety company. And that's a lot of the work that we're working towards and things that we're excited to get input on from all of you guys. So let me scroll through and see if there's anything else really quick. Regulation and requirements of the organizations. Very, very good question by Lou as well on how you interpret organizational requirements versus product requirements. Very good point that safety and HARA can be done before actually designing a product. How do we differentiate between design input and design output? Definitely agreed on not accepting output without human validation. Another Akshay, fantastic. Great to meet another Akshay here. So their benchmark requirements for data sets. We have not found anything yet. We've tried to put some of this together. That's something I'm excited about. So that is one of the things I will wrap up with. Let me just go to the end of this. Closing thoughts. Exactly what a lot of the audience said. Agents are partners, not replacements for systems engineers. Really, really important. That's what we try to drive home with our customers and all the work that we do. Multimodal and structured inputs unlock the most value. That's what programming these systems is most valuable for. It's something that we're excited to show and then help most of you with. Feedback loops grounded in safety analyses improve requirement quality and trust. That is really specific to the kind of work we do, but the general thesis that we want to really hone in on is you want to ground things in analyses and frame the work that an agent can do, even if it's not ready to do it yet. As long as you tell it what it's going to have to do, then you eventually get to the point where you can do that. And you can capture all the information you need without needing a human always in the loop. Last slide on here, our website is just Saphira.ai. My email is super easy, Akshay at Saphira.ai. I'm super easy to find, Akshay Chalana on LinkedIn, Twitter, wherever it's easiest to reach me. I'm on the INCOSE Yammer, so you can find me on there. I think this QR code is to my Calendly, so if you want to book time with me, feel free to do that. You can do the same from the website. And then, yeah, shoot me a call, WhatsApp, whatever is easiest for you guys. Very accessible. Happy to talk however you guys would like. Thank you so much for listening to me ramble for an hour and a half. Really appreciate that and really look forward to talking to more of you in the future.
Thank you, Akshay. That was very good, very insightful. And the recordings, the video, the presentation, all that will be on the INCOSE RWG site for folks to peruse. As a reminder, we'll have a similar presentation later this afternoon. Presentation-wise, pretty much the same, but we do tend to get different questions because it's a different audience. So thank you very much.
Thank you all. Really appreciate you.